today we'll see ethers. Okay, first of all we'll see the name, how it is named, type of common name. Next we will see type of ethers. First one is for ethers. Next one is mixed ethers. Okay. Then we will see method of preparation. Then we will see reactions. So first of all we will see ethers. Ethers are divided into two categories. The first one is simple ethers. Second one is mixed ethers. Simple ethers, the general formula that is ROR, in which the two alkyl groups are same. If we consider one example, CH3 OCH3, or you can see C2H5 OC2H5. Okay. These are the example of simple ether. Next we will see mixed ether, in which the two alkali groups are different. The general formula is ROR dash. If we see example, these two alkali groups, we can name this as different alkyl groups. Okay. Example, if you consider like CH3 OC2H5, okay, or C2H5 OC3H7, or we can say anisole, that is C6H5 OCH3 is known as anisole. Next we will see the common name. This common name for this one is known as dimethyl ether. Due to presence of two methyl group, it is named as dimethyl ether, and this is known as diethyl ether. Okay, and if you see the IUPAC name, this is known as IUPAC name for this is known as methoxy methane. And for this is known as ethoxyethane, and for this the common name is methyl ethyl ether, or we can say the IUPAC name will be methoxyethane. Okay, for this the IUPAC name will be phenoxymethane. Sorry, not phenoxy. This for name this will be the IUPAC name will be methoxybenzene. Methoxybenzene. Okay. These are some of the ethers. Okay. In the next slide, we will see the methods of preparation of ethers. First of all, first method for preparation of ether is by dehydration of alcohol. Okay. By dehydration of alcohol, we can we have seen preparation of alkene by the method of dehydration of alcohol. In on that reaction, it is mentioned as C2H5OH dehydration plus concentrated H2SO4. It forms ethene CH2 double bond CH2 plus H2. This is dehydration of alcohol. Okay. Instead of normal ethanol, if we use excess of alcohol in presence of concentrated H2SO4, this forms ether. Okay. So there is a differential mechanism. Okay. So let's see the mechanism of formation of ether. Okay. First of all, we will start with C2H5, that is ethanol. Okay. Let's start with ethanol, that is C2H5OH. as it is reacting in acidic medium. So the first step will be protonation of alcohol. So there will be formation of CH3, CH2, OH2 plus. Okay. Now this OH2 plus water H2O is a good leaving group. So this will remove H minus of H2O and there will be formation of carbocation. To this carbocation, the next or the remaining of ethanol that will act as a nucleophile. C2H5OH. The lone pair on oxygen, this will act as nucleophile and this will attract the carbocation, and there will be formation of C2H5OH plus bonded to C2H5. In the next step, there will be deprotonation, removal of H plus, and there will be formation of ethanol C2H5 or C2H5. That is known as ethoxy 10, or we can say diethyl ether. Okay. So the next method of preparation of ether, that is by the action of diazomethane on alcohol. Okay. If you react alcohol with diazomethane in presence of HbA4, which is one type of known as fluoroboric acid, one type of acid, in presence of that acid there is formation of ether. Okay. So the structure of diazomethane, that is CH2 double bond N double bond. This nitrogen forms 4 bonds, so it will be N plus. This forms 2 bonds, this will be N minus. Okay. So in the first step, there will be formation of, now this negative charge will transfer here and this will transfer here. So this will be formation of CH2 minus single bond N plus triple bond N. Okay. Now this will protonate through HbA4. This HbA4 will break to H plus plus PF4 minus. This will combine with H plus and there will be formation of CH3 N triple bond N plus. Now this N triple bond N is nitrogen, N2 gas. This is a good leaving group. There will be transfer of electron and there will be minus of N2 as gas. This will be removed and there will be formation of carbocation CH3 plus. Now the ethanol C2H5OH, this will react with this carbocation CH3 plus. The lone pair of oxygen attack as a nucleophile and there will be formation of C2H5OH plus single bond CH3. The next step will be removal of proton. There is formation of C2H5OCH3. Okay, this is one type of mixed ether. The name of the ether is methyl, ethyl ether, or my spec name is methoxy ethane. Okay. Next we will see next method of preparation of ether, that is addition of alcohol to alkene in presence of acids. Okay. So the reaction mechanism will be the first step, there will be protonation of that alkene. Okay. Let us write the alkene. Okay, this as there is presence of acid, this acid will release H plus. So there will be attack of double bond to H plus. If there is attack of double bond to H plus, there are two chances, like the H plus will be attached to this carbon or the H plus will be attached to this carbon. So according to Marconi rule, the H plus will be attached to this carbon, small number of hydrogen. So there will be formation of tertiary carbocation. Okay. The H plus attached to this position, we have formation of primary carbocation. But if H plus attached to this carbon, okay, so if the H plus attached to this carbon, there will be formation of primary carbocation. But if there will be formation of second tertiary carbocation, but if it attacks to this carbon, there will be formation of primary carbocation. So the tertiary carbocation is more stable than primary carbocation. So this H plus will be attached to this carbon. Okay. So there will be formation of tertiary carbocation, and in the next step, the alcohol like OH, CH2, CH3. This will act as a nucleophile. The lone pair will attack to the carbocation, and there will be formation of intermediate. This is methyl or CH3. Methyl single bond OH plus bonded to CH2, CH3. Now there will be minus of H plus or removal of proton, or we can say deprotonation, and there will be formation of ether. Next we will see name reaction of type of name reaction that is used for synthesis of ethers, that is known as Williamson synthesis. In this Williamson synthesis, sodium alkoxide reacts with alkyl halide to form ether. So this is the general reaction, and the reaction mechanism will be okay. Now this sodium alkoxide R dash O minus Na plus, so this will act as a nucleophile. Rx is X means halogen. Halogen X can be like iodine or bromine or chlorine, something else. So this nucleophile negative charge will attack to the carbon, and there will be removal of minus of X minus. Okay. Now this will form R dash O R plus Na X. We consider one particular example like CH3 ONA plus CH3I. There will be formation of CH3O CH3 plus NaI. This is Williamson synthesis. Okay. Next, the action of from alkyl halide, there are two methods of preparation of ether. One using Williamson synthesis and another using silver oxide or dry silver oxide or dry H2O. So the mechanism for this reaction will be this Rx reacts with H2O to form ROR. If there are two Rx or two alkyl halide, there will be ROR dash. So the mechanism will be, first of all, this Rx will react with Ag2O. This oxygen have lone pairs. Okay. This lone pair will first attack to the carbon, there will be removal of X minus. So the bond will be R single bond O Ag single bond Ag plus, now this will react with X minus, attack to X minus, and there will be removal of AgX, and the formation of ROAg. The next step, this will also react with ROH. This will also react with Rx, and the oxygen will attack to the R, and there will be formation of ROR. If this is R2Rx is changed to Rx plus R dash X, so there will be formation of ROR dash or mixed ether. Okay. Next we will see the physical properties of ether. Physical properties of ether, you can see the ether is soluble in water due to presence of hydrogen bonding. You can see the hydrogen bonding between the oxygen of ether and the hydrogen of water. So due to this hydrogen bonding, the ether is lively soluble in water. Okay. Next we will see boiling point. The ethers have lower boiling point than the corresponding alcohols. Like if you consider dimethyl ether and C2H5OH, ethanol and methoxymethane, they have comparable atomic mass. The atomic mass are comparable. But the difference in melting and boiling point are high, because in ethanol there is formation of hydrogen bonding, but in case of these ethers there is absence of hydrogen bonding. Due to absence of hydrogen bonding, the intermolecular force of attraction between ethers are very low. That's why there is low melting and boiling point. Next we will see chemical properties of ether. In the chemical properties of ether, we will see the reaction of ethers with halogen acids or halo acids. There are HX, HX may be HI or HBr. So now this reacts with, let us see the reaction mechanism. The reaction will be, let us see, ROR plus HI. So there will be formation of one ROH plus RI. Okay. Now the mechanism for this reaction will be, okay, this HI, one type of acid, so this will separate to H plus I minus, and this ROR will react with H plus. Lone pair of oxygen will attach to H and there will be protonation. ROH plus and R. Now this group is alcohol. ROH, this is alcohol, so this is stable compound. There will be number of electron formation of ROH plus R plus is carbocation. To this carbocation there will be addition of I minus. If we react with HI, then there will be formation of what? This, there will be formation of R. Okay. And this method, the ethers react with halogen acids such as HI and HBr to form one alcohol and another alkyl halide. Okay. If we react this ethers with concentrated acids such as HCl or hydrochloric acid, there will be formation of oxonium chloride. Like this ROR type, this HCl will separate to H plus plus Cl minus. In the first step there will be protonation and there will be formation of ROH plus R. This is oxonium ion. And due to this presence of like we can also add that overall positive charge. Due to this presence of overall positive charge, this negative charge Cl minus also attached to this. So if we react with more concentrated acid like HCl, there will be formation of like you can see the name of this compound will be dialkyl oxonium chloride. Specifically, if we react like CH3 or CH3, if we react this with HCl, there will be formation of the first step. This H plus will HCl will separate to H plus and Cl minus. So in the first step there will be protonation, there will be formation of CH3 OH plus CH3. Due to this presence of positive charge, the negative charge will be attracted to this total complex and there will be formation of formation of CH3 OH CH3 plus Cl minus. The naming will be dimethyl oxonium chloride. Okay, these are some reactions of ethers. In the next class we will see epoxides, formation, physical properties, chemical properties and reactions. Okay, if you have any doubt, let me know in the comment section. Thank you.